Okay, just a really quick video on how to use the distance formula. So the question that you could find on the SAT or wherever you find your question is, what is the distance between the points negative 2, 5 and the point 3, negative 1? The question may be illustrated this way. How long is the yellow line? And we can see that it has a starting point of negative 2, 5, and it has an ending point at the point 3, negative 1. And hopefully what you can see here is this. I've started to construct this because we're going to use a variation of the Pythagorean theorem. So I just wanted to show you why am I talking about the Pythagorean theorem, is that if I go straight down from here to a height that's the same as the height of this point here and the same x value as this point here, and then make lines, I have a right triangle, don't I? And that's what this little symbol is here, the right triangle symbol. So here is the Pythagorean theorem, and the Pythagorean theorem says that the hypotenuse, a squared is equal to b squared plus c squared, where this value here has to be a. This is b or c. So all I'm going to do is change this. I'm going to trade this, and I'm going to say the distance squared is equal to this b squared. So this side here, which is, we want to know here with the Pythagorean theorem, how long is the side? Right, so how long is, we'll take this side here, and this side here goes from this value to this one. So in Pythagorean theorem, we're going to just say this. We're going to call that x sub 1, so x sub 2 minus x sub 1, it doesn't matter what order you do it in, squared, plus y sub 2 minus y sub 1 quantity squared. And if you just look at this for a second, this side here that we're looking at here is this side here. It's how long is this side. If we were in geometry, we'd be figuring out how long this side is. But we know some starting points. We know that this point starts at negative 2 and goes all the way over to 3. And what is the distance from negative 2 to 3? I think that the distance is 5, isn't it? And here, and then we want to figure out what's the length of this side. And the length of this side, this height starts at 5 and goes all the way down to negative 1. And how far is it from 5, height of 5, to a height of negative 1? Well, the total distance is 6, isn't it? So just to fix it, because we don't want d squared, we don't want to know the distance squared, we just want to know the distance. So what we're going to do here is this. We're going to take the square root of both sides, and we know that the square root of d squared would just be d, wouldn't it? So here, finally, this in this box is the distance formula. So here's our distance formula right here, if you don't mind. All right, so there's our distance formula. And you should have this memorized, actually, because you're going to have lots of opportunities to use this. So what we're going to do is just kind of fill in the blanks here. We're going to have x sub 2 and x sub 1. So the first x value is negative 2. I'm just taking it from here, but I'm just using this because this is the distance I'm measuring from here to here. So it's negative 2 is the first one. So we have negative 2, don't we? And the ending x value is 3, so it's minus 3 quantity squared. In a minute we'll talk about why Pythagoras squared this thing, because he knew that distance had to be positive, and otherwise we would have gotten negative 5 here, wouldn't we? So lends some understanding to it. The original height was 5, and it went to a height of negative 1, didn't it? So we'll take that. The second y value is negative 1, so let me do it this way. It doesn't even matter what order we take the y values in. I can prove that to you in a second, but let's do it the way I started, which is 5, and the second height is negative 1, so minus, this is a negative 1, so minus negative 1 minus negative 1, like that, isn't it? Okay, squared is equal to the distance, here, and then we just start solving, and we have negative 2 minus 3 is negative 5, and negative 5 squared is 25, good job, plus 5 plus 1 is 6, and 6 squared, how do I get this? Negative times a negative is a positive, isn't it? So it's 36, isn't it? And we want the square root of whatever this value is, and we have 25 plus 36 is what? The distance. 25 plus 36 is is 61, right? So D is the square root of 61. I wish they had used a better example than this, but I guess it's fair. The reason I wish they had used a better example than this is that the square root of 61 doesn't work out perfectly. So you can figure it out. It probably comes up to 7 point something, doesn't it? And it does. It comes out to approximately, approximate this, approximately 7.18. So what's the distance? 7.81. Did I say 1.8 last time? 7.81. How far is this distance? It's the same thing, isn't it? It's about 7.81. So here's an example. Here's a definite description of why this is true, and this is a better description of how to use this. After you have this thing figured out why you do it, it really is just as simple as just plugging in the values. So please memorize this. This is the key. Memorize this. Memorize. Use flashcards. Whatever you have to do to memorize that. I'm going to try to post some other examples of how to use this, but I hope that was really helpful to you. The distance formula is going to show up all over the place, and you're going to use it in future math. And if you haven't taken the SAT yet, I guarantee you that there are going to be a couple of opportunities for you to get some really easy points by being able to use the distance formula. And the opposite is true. If you have not memorized the distance formula, there are going to be some really easy questions on the SAT that you're going to have to give up. So please, study, study, study. Memorize, memorize, memorize.